So the first thing we're going to do in this unit, before we move on to anything new, is we're going to sort of review the most important algebra skills you need to remember from last year. We're not going to cover every single thing, okay, but these are the most important things that we'll continue to use this year in grade 10 as we do some new algebra stuff. So the first thing are powers. So what does a power do? Well, it represents repeated multiplication. And it is made up of two numbers. The two numbers together are called the power. The big number is called the base, and the little number up and to the right is called the exponent. And the exponent tells us how many times to multiply the base by itself. So 5 to the third means multiply 5 by itself 3 times. Okay? Again, you don't have to worry about defining words, but when I use words like power and base and exponent, you should know what I'm talking about. Much like some of the words we learned relating to algebra last year. So an algebraic expression is a mathematical statement that contains a variable, an unknown, usually a lowercase letter. It can also contain numbers, which we call constants, and operations, such as addition, subtraction, multiplication, division, exponents. There are other operations, but we're going to focus just on these this year. If numbers and variables or a combination of the two are separated by adding addition and subtraction signs, we call those individual things terms. Again, only have to worry about just, you know what I'm talking about when I say those words. So as an example, we've got 5x squared minus 3. So it's an algebraic expression. It has two terms in it because they're separated by a subtraction sign. And the terms are 5x squared and negative 3. The x is a variable, negative 3 is a constant because it doesn't have a variable with it. The 5 in front of the x squared, which means it's being multiplied by x squared, is what we call a coefficient. So a coefficient of a variable is some number in front of a variable getting multiplied by it. Okay, let's actually look at a few questions. So what you should be familiar with. How to evaluate algebraic expressions. So for example, if I give you the algebraic expression 4x minus y plus 10, how many terms are in that expression? 3. Okay. How many variables are in that expression? 2. What is the coefficient of x? What is the coefficient of y? Negative 1, because there's a minus in front. What's the constant? Okay, so you should just be familiar with that. So how do we evaluate this if we're told that x is 4 and y is negative 3? Well, we just simply, every time we see an x, we replace it with 4. Every time we see a y, we replace it with negative 3 in parentheses. The parentheses are very important, especially when you have questions that involve squaring or multiplying. So that's what it looks like. So that means I got to go 4 times 4, subtract negative 3, and add 10. What do I do first? Four times 4, which is? These two make, so 16 plus 3 plus 10. And then we can do all those together. 28. Let's try 29. Thank you. Okay, this next one's a little bit more complicated. But again, every time you see an x, replace it with 3. Every time you see a y, replace it with -2 using parentheses. So instead of x, I'm going to write 3. Instead of y, I'm going to write -2, but then after the -2, there's a squared. -2 times there's an x, so replace it with 3, and that 3 is being cubed. What do we do first? The exponents. So I'm not going to touch the 3, but I have to do -2, and this is where parentheses is important. Okay, the negative's in with the 2, so it's -2 all squared, which is what? +4. Remember, this is +4. This is -4. Okay? Parentheses matter. And then -2 times, well, what's 3 to the third? 27. Now we can do our multiplication and get 12 minus 54 to get a final answer of -42. Okay, so we should be familiar with these type of questions, how to evaluate algebraic expressions using substitution. Collecting like terms. Knowing what like terms are and how to combine or collect them. Let's just jump into the example right away. What would you consider like terms in this example? Sorry? The x's and the y's. So for the x's, I've got a 6x minus a 2x, which is 4x. And for the y's, I've got a 3y positive plus a 10y. And we need the plus in front. Okay, that's pretty straightforward, I think. If there's exponents involved, remember, like terms, we're adding and subtracting here. We're not multiplying and dividing. So like terms have to have the exact same variables and the exact same exponents. So what would be a pair of like terms here? Which together make? Right. Remember, it's not an exponent law question. We don't change the exponent unless we're multiplying or dividing or raising one power to another. Another pair would be -8x squared plus 9x squared, which gives us plus 1x squared or just plus x squared. We've also got a -3x and a -6x, which give us. And we've got a +3 and a +1, which give us +4. And you can't go any simpler than that. Okay, so that's adding and subtracting with and without exponents. But what happens if we start multiplying and dividing? Well, let's start with multiplying first. You can multiply two powers together that have different exponents. Do you remember how to do it? So let's, yep. And what happens to the base? Stays the same. So for this one, we would get x to the 9. Be careful with this next one. Anybody? Seven to the ninth. The base stays the same, even if it's a number. You don't multiply the sevens together. We could have more than one variable with exponents here. Remember, just think of this negative as -1, a squared, b to the 7th times a to the 3rd, b to the 5th. Well, our answer is going to be negative because we got a negative times a positive. When I multiply the powers of a together, what do I get? 8 to the power of 5. When I multiply the b's together, b to the 12th. There's coefficients in front, numbers in front, multiply the numbers, and then multiply the powers. So remember, it's only the exponents we add. We don't add the coefficients, we got to multiply them. So what's -7 times -3? 21. And now I have to multiply the powers of t. T to the 4th times t. Remember, t is still the same as t to the 1st. So when we multiply them, we get t to the 5th. Exactly. Try E. Go for E. You can do E, you're in good shape. Multiply. Anybody want to take a shot? Multiply the coefficients to get -10. Multiply the powers of x by adding the exponents to get x to the 8. Multiply the powers of y by adding the exponents to get y to the 5th. Well, when we multiply powers together, we add the exponents. So when we divide powers, what do we do with the exponents? Subtract them. Whoops. Just one more example to do. Forgot about it. Jumped ahead a little too much. Oh, this one. What are you going to do with this one? Can you combine anything inside the parentheses? No. Ella? Exactly. We have to multiply the 5x by everything inside. And remember, every time you see an x, that's the same as x to the 1st when you use your exponent laws. So what's 5x to the 1st times x to the 3rd? 5x to the 4th plus 5x times 3, 15x, minus 5x or 5x to the 1st times x or x to the 1st. 5x squared. Remember, x plus x is 2x. But x times x is x squared. Now we go to dividing. As you say, we subtract the powers, or subtract the exponents, pardon me. So, what do I get when I divide x to the 11th by x to the 10th? X to the 1st, or just x. Don't need to write the 1. If you wrote the 1, I'd still give it to you. Watch out when the bases are numbers. What would this one be? 7 to the 4th. This next one, well, I don't have any coefficients, or they're 1 anyway, but I do know my answer is going to be negative because I got a negative divide a positive. So now just divide the powers of y and divide the powers of z. Well, we get y to the 3rd. What happens to z to the 3rd divides z to the 3rd? Yeah, because anything divide itself is 1. So really, I mean, if I actually divided this and wrote something here, I'd write it times 1. But anything times 1 is just itself. So you never need to write a times 1. So yes, they disappear. Try the next two. Remember, when a variable doesn't have an exponent, we always assume it's 1. D? Anyone? North? -6. M to the 3rd, correct. E? Avery? Right. So remember, this a down below here is the same as a to the 1st. We did learn another exponent law. Or did I? Nope, that's right. And that's when we take one power and we raise it to another power. What do we do with the exponents then? You multiply them. So what would the first one be? A. Base stays the same, multiply the exponents. What would B be? 5 to the 10th. Now, sometimes it gets a little tricky when there's a coefficient inside. Remember, you have to cube everything inside. So this means I've got to do 3 to the 3rd and then times that by p to the 5th to the 3rd. Well, this isn't an exponent law. This is just a straight evaluation. What is 3 to the 3rd? 27. Now this one is an exponent law. What does this give me when I simplify it? P to the 15th. So watch out for that when there's a number, a coefficient inside getting raised to an exponent. You got to raise that. It doesn't stay as 3. And remember, when we take an exponent, it's multiplying, not adding. Common mistake students will make is they'll think that's 9. Because they think, well, I multiply these, so I should multiply these. But this is not an exponent. This is a base. 20. Oh, that doesn't look quite right. Put it down there. Everything inside has to be squared. Anyone want to take a shot? Sure. Nice. Perfect. All right. I know we got lots of time to finish this, but I don't want to jam a whole bunch of stuff in. So we're actually going to do this tomorrow or Thursday? Thursday. We're going to do this Thursday, the equations. Let's just stop at the simplifying right now and do a little practice with that. So what I would like you to do for Thursday, please, and you've got the remainder of this class to do it, is exercise 1.1, numbers 1 to 6. I mean, if you want to do the equations in 7, that's fine, but we'll talk about the equations on Thursday. I want to, like I said, I don't want to jam. That's enough for today.